right, hello everyone. So we have a trigonometry problem that we're working on today. So we have find the area in red that lies inside the circle radius 7 pictured above. All right, so let's first of all take a look at this triangle that lies inside the circle that's formed by the points O, A, and B. So this triangle would be an isosceles triangle. Why? Because you have two sides here that are of the same length. Because the length from OA and OB, those are the length of the radius, so they have to be the same. So it's 7. So two sides of our triangle being equal, that is an isosceles triangle. Now, the idea to find that area in red, let me call that A red here, is as follows. And this often happens in this class where you're finding the area of a specific part of like this little region here in red, and it amounts to looking at the difference between two areas. So if you look at the area that I'm forming here in red, which is basically everything that you see encapsulated in that sector, essentially, it goes from A to B. The area of that sector, if you take that area minus the area of the triangle, let me write more like a subscript here, so sector, that would give you the area that we want in red. Okay, so that is how I plan on figuring out this area right here. Okay, so again, it's the area of that whole sector minus the area of the triangle. Okay, now, and how do I figure out, first of all, that area of the sector? So we have a formula that says the area of the sector of a circle is 1/2 r squared theta, but theta has to be in radians, okay? So I don't have that here. My angle is 65 degrees. So I'm going to have to convert degrees to radians. And how do I do that? Well, 65 degrees times pi over 180 degrees would be 65 pi over 180. And you could reduce this by 5. 5 goes into 65 13 times. 5 goes into 180 45 times. Or I'm sorry, no, 36, excuse me. So 13 pi over 36 radians is what 65 degrees is equivalent to. So my area would be 1/2 times 7 squared times 13 pi over 36. So it'd be 49 over 2 times 13 pi over 36, which would come out to 72 here, pi, and then 49 times 13. Gives us 637. So it'd be 637 pi over 72. All right, so that is what our area would come out to for that sector. And let me write that out, sector. And now for the area of that triangle. So for this triangle, the area of a triangle, we know the formula is 1/2 the base times the height. The issue here is I don't really, if I pick a base, the base of a triangle can be any one of the three sides here, by the way. It would be a little difficult finding the height for us. Not too bad, but what I'm trying to get is you can't put numbers in directly into that formula of A equals 1/2 base times height. Let me just write that down here, times H. Let me write the word area here, not to be confused with that little a. So I can't use that formula here, so what can we do? Well, a couple things. There's a formula from your trig class that says if you have a triangle, which is this, and if you have two sides, call them A and B, lowercase, and an included angle, which is basically an angle in between the two sides, the area is equal to 1/2 the product of the sides times the sine of the angle. So in our case, that would be 1/2 going back up to this triangle right here. the two sides are 7, they're actually the same. So 7 times 7 times the sine of the angle, so times the sine of 65 degrees, okay? So this would be 49 over 2 times the sine of 65, and I don't need to do any conversions here, by the way, in terms of radian. That's how this would work out. Okay. Now you have another option. You're like, I don't really, not into remembering formulas. Well, we can derive that. The idea here is if you draw a perpendicular, an altitude, I'm sorry, from A here, and it could have been any point, but I'm just trying A here because I think it's the most convenient. You have a right triangle, and you have an angle that's 65 degrees that you see there. Let me rewrite it. And the point that I'm trying to get at here is that you can find the area using the 1/2 base times height formula. So it would be 1/2 times my base of my triangle. So if I were to take OB to be the base, that'd be 7. And then the height here, well, what's the height? Well, you could figure that out with trig. If you look at the triangle formed by OA and this point right here where you have an angle of 90 degrees, you could use trig and say the sine of 65 degrees is equal to the height over 7, or 7 sine 65 degrees. So that is how you would get that answer without using that formula, but they're equivalent, as you can see. All right, so either way works out. And your final answer for the area in red here was the area of a sector of a circle, which is the 637 pi over 72 minus 49 over 2 sine of 65 degrees. Okay, and yeah, you could obviously put this into a calculator and round this to some number if you prefer, instead of an exact answer. And I'll let you do that. But that's the way we would go about doing like the area of a section of a circle that is equal to the difference of two objects whose areas we know. So, it was the area of the sector, which is, I like to think of it as a slice of the pie, minus the area of a triangle. Okay. All right. Well, thank you very much for your time, and I hope this helps.